Alrighty, y'all. Today we're taking a look at question 3 for recitation 14. And for this one, we're trying to find the electric field inside of a wire. Alright, so we're going to start by calculating our current density, right, which is just the current divided by the cross-sectional area, right? So we're given the current of 0.83 amps, right? And we just need the cross-sectional area. So since we have a 1 millimeter diameter, that's going to give us a 0.05 millimeter radius, right? Because diameter is twice the radius. And then that's going to be, if we're getting everything into base units like we always do, 5 times 10 to the negative fifth meters, right? So you're just going to multiply by 10 to the negative third. And then that means that our area, since it's just a wire, our cross-sectional area is pi r squared, just a circle, which is going to be pi times 5 times 10 to the negative fifth squared, right? So that's going to give us that our current density is going to be 5 times 10 to the negative fifth squared, all under, oh, it's gross, all under 0.83, right? And again, we have amps, we have our meters, everything's going to stay in base units. So that's going to give us a current density. And we also have the definition of the resistivity when we're calculating that for any given material. That's just the electric field divided by our current density, right? So using this, we can plug in our current density into here, and we're given the resistivity of tungsten. We plug that in here, and we can solve for our electric field, right? So we have our resistivity, 5.6 times 10 to the negative eighth equals E over that, because I'm too lazy to write it again, right? And this is just our big dividing line between those two, right? We have our numerator and denominator there. All right, so if we're solving now for our electric field, we're just going to multiply both sides by that current density. So it's just going to give us that it's 5.6 times 10 to the negative eighth times 0.83 divided by pi 5 times 10 to the negative fifth squared is going to equal our electric field, or the magnitude of the electric field. We don't have the direction. But evaluating all this out is going to give you your correct answer. However, on Kudu, I noticed this was a problem, at least to begin with. I don't know if they fixed it yet or not, because so when I submitted this answer, it told me it was wrong. And I was like, I checked all my math. I'm pretty confident in this one. So then I went back through, and instead of using 0.1 millimeters as the diameter, I just plugged this in as the radius, and that actually gave me the answer that Kudu marked as correct. So in reality, when you're finding the area of a circle, you're using pi r squared, so you have to make sure that if you're given the diameter, you divide by 2. But for this specific Kudu problem, the answer actually has the error in it, so in order to find what's the actual correct answer on Kudu, it's going to be 5.6 times 10 to the negative eighth times 0.83 divided by, but this time our area is just going to be pi. It's going to be 1 times 10 to the negative 4 squared, right? Because we're not, and that's going to give you what's marked as correct, technically marked as correct on Kudu, but this is going to be like your actual correct answer using the radius, not the diameter. Right? And I'm only partially confident that that's the right conversion to meters of 0.1 millimeters. Yeah, that's right. That's right. But yeah, this is your correct answer on Kudu for this week. And I sent an email and asked if this was right or not. But this is your correct answer overall. That's going to get you like the actual answer. That's not just a mistake one. Hope that wasn't too confusing. Anyways, Thank you all so very much for watching. I hope you found this video at least a little bit helpful, maybe a little confusing. Let me know if you have any more questions on this problem or any other problems that you want me to try to explain, and I will do my best to explain them because I guess Sydney explains stuff.